Hello class, welcome to the next segment in lecture 25, and in this segment we're going to talk a little bit about how pollution gets into the atmosphere in the first place, and also talk about some of the atmospheric uh, factors that we look for to diagnose an atmosphere that is especially favorable for high pollution levels or high accumulations of pollution. So that's going to be the topic for this segment, and let's go ahead and dive right into it. So one source of pollution, or these, we kind of already alluded to these in the previous segment when we were talking about air quality index and what usually causes especially high values of air quality index, one of which is human activity. A lot of that stems from industrial areas or power plants can release various types of pollution into the atmosphere, and also vehicles, whether that's a truck, a car, a train, whatever it might be. Anything that gives off some sort of emissions of from a combustion reaction can be a source of air pollution. And human activity is one of them, but usually a much greater source of air pollution is going to be something like a massive wildfire or a really big volcanic eruption. Wildfires can release a lot of combustion byproducts into the atmosphere, and they can actually go very high into the atmosphere. On occasion, you can get wildfire smoke that goes all the way to the stratosphere, to the top of the troposphere. And also, volcanic eruptions can extend to the stratosphere. And those are particularly impactful because, as we'll see in some later segments, volcanic eruptions can release a ton of aerosols into the atmosphere. And if you get an especially powerful volcanic eruption that releases aerosols into the stratosphere is a very stable layer of air, meaning you don't have a lot of turbulent mixing. The flow is pretty laminar, versus in the troposphere where you can mix out the aerosol concentrations and lower the concentrations. You can't really do that in the stratosphere. So if you get a volcanic eruption that releases a lot of aerosols into the stratosphere, then those aerosols are going to be there for a really long time. And one of the properties about aerosols is they tend to be very good at reflecting solar radiation. That's one of the reasons why big time volcanic eruptions are associated with a major cooling effect on the areas below it because of the high concentrations of aerosols that are present in the atmosphere for such a long period of time. Wildfires can also generate large concentrations of aerosols, but wildfire smoke rarely penetrates into the stratosphere. Volcanic eruptions are much more likely to get into the stratosphere. The wildfires can also inject aerosols into the stratosphere if they are sufficiently intense. And another one that isn't as frequently talked about is ocean currents can actually transport pollutions around the world, but you can also get, we talked about upwelling when we talked about the El Nino Southern Oscillation. Sometimes certain types of pollutants can rest deep into the ocean, and then at some point they can be brought back up to the surface where they can then find themselves in the atmosphere and potentially impacting the ecosystem that they're nearby. So oceans can also be a source of pollution just by the fact that some pollutant was put in the ocean to begin with, and then the ocean transports that to some other part of the world. So, something else that is also something to keep in mind, that's another potential source of pollution, but usually wildfires and volcanic eruptions, those tend to be the most common sources, and to some extent human activity, depending on how much emission is due to the human activity, can also be a substantial source of pollution in the air. So those are some sources of pollution. Now let's take a look at some of the atmospheric factors that can favor large buildups of atmospheric pollution. So I just mentioned that usually the pollutants or stuff that gets released in the troposphere is mixed out because the troposphere is largely an unstable layer of the atmosphere. It's very easy to generate turbulent motions or rising motions that can carry pollutants away from ground level and thus limit their impact on anything that's at ground level. But as it turns out, sometimes the atmosphere doesn't cooperate that way. In fact, if you have a really stable troposphere, then you don't get those rising motions that carry the pollutants away from the ground. So if you have a really stable atmosphere, that tends to trap or keep the pollutants, whatever they might be, closer to the ground level, which means you have a higher chance of those pollutants potentially impacting the ecosystem and also human life or any animal life for that matter. And another thing that is important to keep in mind is the strength of the winds. Usually, stronger winds encourage turbulent mixing, and like we said, that tends to lower the concentrations of pollution. If you're mixing high concentration with low concentration, you tend to lower the overall concentration in the atmosphere. But if you've got really weak winds, which is something that's very common to encounter in the summer, then you won't have that turbulent mixing, and that allows the concentrations of the pollution to build up to higher levels. In fact, this is one of the reasons why air quality alerts are most often issued in the summer, because the atmosphere in the summer tends to be very stable in many parts of the world. And also, the winds in the summer tend to be a lot weaker because in the summer you're much more likely to get a barotropic atmosphere, which doesn't produce a lot of winds. And if you don't have a lot of winds, then you don't have a lot of turbulent mixing that would otherwise lower the concentration of pollutants that might be present in the troposphere. And another reason why pollution is so prominent in the summer, I'm not saying you can't get pollution in other seasons, but usually this is most common to see during the summer, is strong heating. And we kind of talked about this when we were talking about the urban heat island, how you can get, due to the differential diabatic heating, uh, you can actually get convergence over a very urban area. You can get a wind that's all moving towards the center of an urban area. And if you've got something like that in place, along with a lot of pollutants, then you can have a lot of pollutants converging to a common point, which can then serve to increase the concentration of pollutants and over a large urban area. Another factor that's important to consider, and we'll talk about this a little bit later on when we talk about nitrogen oxides, but high levels of ultraviolet radiation are something that can produce higher concentrations of tropospheric ozone, which, again, we don't like ozone in the troposphere. Stratospheric ozone, great. Tropospheric ozone, not so great. We don't want that in the troposphere if we can avoid it. And another factor is hilly terrain. This isn't really a meteorological factor, but it is something that we have to keep in mind, because in a hilly area, you're much more likely to get a layer of warm air aloft. And we kind of talked about that when we were talking about the elevated mix layer, how when you heat up the air over elevated terrain and then bring that air over lower terrain, you basically form a cap, which is a layer of warm air that tends to suppress upward motions. And if you get the conditions just right, that warm layer of air aloft can create a very stable atmosphere. And if you've got a really stable atmosphere, then those pollutants are not going to be escaping into higher altitudes. They're going to be staying closer to ground level. In fact, we'll take a look at a photograph that will sort of illustrate this, as well as some other photographs. And you can see how in this particular region, you can see there's hilly terrain off in the background. And you can also, if you look really carefully, you can see some sort of upward plume. And then as this rising column of air goes upward, it doesn't seem to go up any further. In fact, just looking at this pattern, you can see how it goes up and then it hits a stable layer of the air. And usually when that happens, the updraft will disperse outward. So you have an upward current of air, hits a stable layer, and then it just disperses outward. You get a lot of divergence once it hits that stable layer of air. So you have a lot of smoke or whatever this might be going upward, and then it's just dispersing. And you can see, you can sort of see how the extent of this, because you can see how there's a layer of smoke, and then right above that, the atmosphere is very clear. So that would tend to suggest that you've got some sort of inversion, which is a layer of warm air aloft. You got some sort of warm layer of air aloft, which is resulting in a very stable atmosphere, and it's preventing from this rising column of air from escaping into a deeper part of the troposphere. So as a consequence, all the smoke and pollution is kept closer to ground level, which means the people who live here are probably not very happy. So because the air is just really ugly outside. So that's sort of an illustration one, as which sort of pertains to how hilly terrain can produce atmospheric pollution, but just even more fundamentally than that, this is sort of illustrates how if you have a warm layer of air aloft that is a very stable atmosphere, it can trap all the pollutants closer to ground level, which is not where we want them. And this is a photograph of Los Angeles, and you can see how one of the interesting things about Los Angeles is it rests in a pretty deep valley. There's a lot of mountainous terrain around the city. And again, it's the same idea that we looked at in the previous photograph. So you have the hilly mountainous terrain, and then you can see how at one level in the atmosphere you have all this pollution that's trapped, and then above that the air is perfectly clear. And it's the same idea. It's the same thing that's going on. You have a layer of really warm air that sits on top of the lower elevations, and that's resulting in a very stable atmosphere. This pollution wants to go upward if it can. There's updrafts or upward currents of air that are trying to bring this pollution upward, but they can't penetrate the warm layer of air that's aloft, so all the pollution stay trapped closer to ground level. And similar thing happens a lot of the time in Mexico City. So this is a photograph of Mexico City, and you can see again mountains off in the distance, which is very good at generating those warm layers of air aloft, which result in a very stable atmosphere. and you can sort of see the same thing. It's not quite as pronounced in this photograph. It sort of looks hazy even above this big cloud of whatever that is. I don't know. It's just it's probably not something you want to be breathing in, and we'll just leave it at that. But it's the same dynamic. Warm layer of air aloft. You don't get a lot of turbulent mixing because the wind's probably really weak, and probably really hot as well. This is probably in the middle of summer, or even in Mexico City. Mexico City is at a very low latitude, so you're much more likely to get a barotropic atmosphere that occurs year-round. So in the equatorial regions or in the tropical regions where you have where barotropic atmosphere is much more common, you have a better chance of getting year-round pollution as opposed to some of the higher latitudes, like say between about 25 and 45 degrees north. Usually, most of your big pollution concerns are going to be in the summer, where the atmosphere transitions to be barotropic, and then at some point it transitions to being baroclinic, which introduces a lot more turbulence, and this can lessen the degree of pollution in the atmosphere. And then Beijing, China, just a photo of Beijing, China, and this is bad. Like, there's no other way to put this. Like, you can't even see the buildings they're actually supposed to be buildings there, but it's really hard to see them just because the concentration of pollutants is just so high. In fact, China is pretty well known for having really, really bad pollution levels. It's just you don't want to be breathing in this air either. We'll just leave it at that. You can't really see a whole lot of atmospheric stuff here just because the vision, you can't really see a whole lot here, but there's probably a lot of those atmospheric factors that we talked about are probably coming to play. This pollution can't be taken upward away from the ground because of the stable air that's probably above the ground. But yeah, that just I wouldn't want to be breathing in this air. We'll just go ahead and leave it at that. But that's going to do it for this segment on what sort of factors we look for in the atmosphere to diagnose the potential for high levels of pollution. And in the next segment, we're going to talk a little bit about some of those main pollutants that we introduced earlier and sort of illustrate why we care about those so much. So with that, I will see you all in the next segment.